In this experiment, we are going to implement and simulate CS amplifier using N-channel enhancement type of MOSFET and to study the input and output relationship of the signal, and in the second part to plot the frequency response and find a bandwidth of CS amplifier. So to do this, we are using Multisim simulator. So this is our Multisim simulator, and in this we are going to build the CS amplifier. So for that we have to take a MOSFET. So to place this MOSFET in this working area, go to the place, component, then on the left hand side in all groups click on transistors. In that transistor select MOS enhancement N and place it here. After doing this, we have to take resistors. So click on all groups. Here you find resistor rated. So take this resistor. We require total 5 resistor. One is for voltage divider circuit. So place it here. Second resistor is the second component of voltage divider circuit. Then we require drain resistor. So we will keep it at the drain side. One more resistor at the source side, and we required one resistor for the at the load side, so it is connected like this. After placing all these resistor, we will connect it to the circuit. So we'll change the rotation of all those resistor vertically. To do this, select a particular resistor and shift Ctrl R. Similarly, for this resistor, Ctrl R. For all the resistor, we are performing the same operation, Ctrl R, so that their orientation will change, and for this resistor, Ctrl R. Then we'll connect it with the connecting wire. So all the resistors are to be connected according to their connection. So let's say this is for potential divider circuit. Similarly, the RD resistor is to be connected to the drain terminal of the transistor. Source resistor is to be connected to the source side. Then the gate side is to be connected at the potential divider bias circuit. So this is to be connected like this. Then these are to be connected together because power supply is to be applied. So these two resistors are connected above two resistors, and similarly these below two resistors are connected together. Afterwards, we will apply power supply and ground supply at the respective terminal. Then we have to pick up the capacitors. So two coupling capacitors we require and one bypass capacitor. So to place the capacitor, go to the place, component, in all groups. Now you type in the component as capacitor and select capacitor rated. After selecting this capacitor rated, place one capacitor at the input side, input coupling capacitor, another capacitor at the output side, which is output coupling capacitor, and one more capacitor as in bypass capacitor. So for the bypass capacitor, we have to change its orientation vertically and hence Ctrl R. After placing all these capacitors, connect them to the circuit. So this coupling capacitor is connected at its position. Similarly, the output capacitor is to be connected. This output capacitor is connected to the load resistor. So this is connected like this, and this load resistor, the second terminal, is connected to the ground. Similarly, the bypass capacitor is connected across this resistor, and then its second terminal is to be connected at the ground side. After that, we have to take the input signal source and the power supply source. So to take this, go to the place, component, in all groups you have to click on the sources. So click on the sources. On sources, click on the power sources and then click on the AC power and say OK. and place this AC power source as an input. Similarly, in the power sources, now go to the DC power to take VDD and the ground supply. Select this VDD from this component and place it at the above. Now take a ground terminal and ground pin and connect this ground pin at the bottom of this circuit. After placing the power supply pin and the input signal pin, connect it to the circuit. So this input signal is connected to this coupling capacitor C1 and its another terminal is connected to the ground. Similarly, this VDD is to be connected in the circuit and ground terminal is also needed to be connected. So this is our circuit diagram for this CS amplifier. Now we will change the component names and the component value. So very first thing, we will be changing the value of resistor. So double click on this R1 resistor. Take its value to be equal to 20 mega ohm. So 20 capital M. So value will change to 20 mega ohm. This resistor R2, we will be changing its value to 10 mega ohm. So 10 and capital M. Then this R3 resistor, we will changing its name first. So go to the label and say it's RD resistor because it is connected at the drain side, and then we can change its value. So label, you can see here value is also written. Just click on that and select this resistance value of 2K. Similarly, we have to change the value of this R4 resistor. First we'll change its label. R4 is to be changed as RS resistor, that is source resistor, and value is to be selected as 1 kilo ohm only. So it is by default selected. Click on OK. Now we'll change the value of this load resistor. Double click on this. Label will change to RL and press on the value. The value is to be selected 1 kilo ohm. So it is by default selected and press on OK button. After changing all those resistor value, now change the value of capacitor and their names. So double click on this C1 capacitor first. Let us give the name to this C1 capacitor as C input and value you consider as 10 microfarad. So for 10 microfarad, 10 and press U in your keyboard. Press OK. Similarly, C2 capacitor is the second coupling capacitor at the output side. So we'll give the name as C out. Change its value to 10 microfarad. So 10 U. Press OK. Third, double click on C3 capacitor. Give the label as CB, which is a bypass capacitor, and change its value to 100 microfarad. So 100 U and press on OK. After changing all these names and respective values, now double click on the input voltage source. So this input voltage source will give the label as V input. So type V in, change the value as 35 millivolt. We have to apply lesser voltage in terms of millivolt. So type 35 millivolt small m and select frequency up to 10 kilohertz. We are applying a signal frequency of 10 kilohertz and then press on OK. You can see here the value of input voltage source has been changed. Now you can shift this name to the left hand side for simplicity of this diagram. Even I can change this name towards this left side. Now here is our V in voltage source, input voltage source. Now we'll change the value of VDD. Double click on the VDD and set the value is equal to 15 volt. The name will remain same as VDD. Press OK. Now to measure the voltages at the input side and the output side, we are connecting two indicators in the circuit. So to place it, go to the place, component, then go to the all groups. In all groups you find there is an indicator. In all groups you find there is an indicator. Click on the voltmeter and select voltmeter V because we have to place it vertically, so voltmeter V, and press OK. So I am pressing one voltmeter at the input side and place another voltmeter at the output side. Now connect both these voltmeter in the circuit. So we are connecting the first voltmeter at the input side. Similarly, connect another voltmeter to the across the output of this circuit. So across this load resistor we are connecting. Now both these voltmeters should be AC voltmeter, but by default it gives you a DC voltmeter. So to select as an AC voltmeter, double click on this voltmeter. First we'll change the label of this. So instead of U1, I will call this as an input voltage voltmeter. So let's say VI, and go to the value and change the mode of this voltmeter from DC to AC. So I will be selecting AC and press OK. You can see the name has been changed as well as its mode has been changed to AC. Similarly, double click on this output side voltmeter, change the name of this as VO and go to the value and press on mode and select AC mode. Now here also you see the name has been changed as well as it has been converted to the AC mode. Now to see the input and output voltage, we will simulate this circuit for once. So click on this run button. After clicking on this run button, you find the value of input voltage source is 0.035, which we have applied as an input voltage source 35 millivolt, and this voltage, input voltage, is get amplified, and at the output we can see the voltage is 0.545 volts or 545 millivolts. So this input voltage has been amplified with the help of this CS amplifier. Now to see the input and output waveform on the CRO, we will be placing a CRO on this working area and we'll check its input and output waveform. Before that, I will stop the simulation. Now, to place the CRO, go to the right side of this working area where you will find there is a column where all these multimeter, wattmeter, function generator and cathode ray oscilloscope are available. So click on the oscilloscope and place it over this area. Now in this CRO we have two different channels, channel A and channel B. We are using channel A for input signal. So I am connecting the positive terminal of this channel A at the input side of this circuit, and after doing this I am changing its color. So to change the color of this net, you have to double click on this and give the preferred net name to this. So let's say I am calling this net as V input. So please give the name to this net as V input. If you want to change the color of this to, let's say, blue, I am selecting a blue color for input signal, press OK, apply, and then again press on OK. You can see the net color has been changed to blue color. Now connect the second terminal, which is a negative terminal of channel A, to the ground side. So I am connecting this to the ground side. I will be using black color for the ground terminal. So net color I am changing to black color. So I am selecting black color for ground net, apply and OK. Now we are connecting channel number B, positive terminal, to the output of this circuit. So it is connected like this. Change the color to green, and let's say I'm giving the preferred net name as V output. So changing the net name to V output, and I'm changing its color to green. So my output is in green color. Press OK, apply, and again OK. So you can see the output net has been changed to green color, and similarly this output B, negative terminal of channel B, is to be made grounded. So I am connecting it to the ground terminal. By default it gives you blue color, black color here. So this is what our channel number B. Now to see the waveform, just click on the run button and double click on the CRO. You can find the frequency is very low, time division is very low. So we will reduce this time per division to, let's say, 200 microsecond per division. For channel A also, which is in blue color, I am decreasing its scale so that you can find this blue color waveform is there. And similarly for channel B, which is green in color, which is our output, I am changing its time per division. So you can change it up to visible, and then we can stop this simulation or pause this simulation. So to pause this, you can find this F6 button is there. So if you click on the pause button, you can find there is a this you can clearly see that there is a phase shift between your input signal, which is a blue in color, and output phase shift, which is amplified. Now if you want to change the background of this CRO screen to white, click on the reverse button. So here you can clearly see our blue color waveform, input waveform, and output waveform, which is amplified output voltage waveform, and 180-degree phase shift between your input and output signal. Now to plot the frequency response, I will stop this simulation. To do the second part of this experiment, where we have to plot the frequency response. To do this, you have to go to simulate, click on analysis and simulation. In this active analysis, you have to select AC sweep. In AC sweep, frequency parameters, let us consider the start frequency from 1 Hz, and stop frequency is, we have to see this frequency response up to 1 gigahertz frequency. We are selecting sweep type as decade sweep type. Number of points 10, and vertical scale we are considering a logarithmic scale. After changing to these settings, go to the output. In the output, we have to add the gain equation here, and therefore click on the add expression. In add expression, the gain is the ratio of output voltage divided by input voltage. So on the variables, you can find there is a last option V output. Double click on this, divided by. In the function you find this option is there, division or divided by. Just double click on that and take the input voltage from the variable. So double click on this input variable. So you find this expression is there, V output divided by V input, and press on OK. Once you press on OK, you find this expression has been added in the selected variable for the analysis. After selecting this, click on the run button. So once we click on the run button, we find we get two different graphs here, or the plots here. One is the frequency response plot, which is the upper one, and second is your phase response or phase plot. For time being, we are interested in the frequency response plot. So I am clicking right click on the lower part of this graph, and for time being delete this graph from this window. Now To change the thickness of this, right click on this red color, which is a frequency color graph, and trace color. You can change the color as well as you can change the width of this. I'm changing the width of this so that it can be easily visible to us to 5. And to change the background of this waveform, we can go to graph and click on black and white colors. So you can see the color has been changed. Now to see this complete response on the grid, or you can say that a semi-log graph paper view, you have to go to this graph and click on the show grid. So you can find the grids are shown like your semi-log paper. Even the scales are written or they are appear on the y-axis and on the x-axis. Now we have to find out the bandwidth of this frequency response. So to do this, we have to first place the two cursors. To place the cursor, you have to go to the cursor, click on the cursor and click on the show cursors. So here you can see there are two cursors appear, cursor number 1 which is red in color and cursor number 2. Now to find out the bandwidth of this response, you can find there are four variables related to this cursor. X1 and Y1 are belongs to cursor number 1, while X2 and Y2 they belong to cursor number 2. So to find out the lower cutoff frequency, we will be using cursor number 1. So initially what you have to do is place the cursor in the middle of this graph so that I can come to know the maximum gain of this amplifier, which is equal to 15.73. I am reading the value of Y1 which is 15.73. So gain is always bandwidth is always calculated at 3 dB frequency. So 15.73 minus 3 dB which is 12.73. So you have to shift this red color cursor to the left hand side till you get y1 value is equal to 12.73. So I am shifting this red cursor towards the left side and I will stop when I reach to the value of 12.73. So you can see here the value is approximately equal to 12.70. So I will stop here considering approximate frequency as 12.70 gain value. Similarly, this second cursor x2 value should stop at 12.73. The value of y2 cursor should stop at 12.73. I am moving this blue color towards my right side and I am checking the value of y2 in this cursor window. Now the value is approximately equal to 12.70. So I will stop here. Now you can see the value of in this particular window you find the value of y1 is 12.70, y2 is 12.70, which gives you the gain value which is at 3 dB frequency, and corresponding frequencies are given as x1 which is my lower cutoff frequency which is 54.7842 and x2 is equal to 3.73. Now to find out the bandwidth, we can insert this bandwidth in this graph. So go to the graph, click on add text and here you can say bandwidth is equal to higher cutoff frequency in this case is 3.7316 megahertz minus lower cutoff frequency is 54.7842 which is hertz. So this will give you the value of bandwidth. Now to change the name of this graph, you can double click on the AC strip and you can write as frequency response of CS amplifier. Once you type this, press apply and OK, you find the name has been changed. Now this is the frequency response of the CS amplifier, and this way you can calculate the bandwidth of the CS amplifier. Thank you.